Hey everyone, it's Miss Mac here with another short video. This time we're starting a new topic called quadratic functions. We have 3 learning objectives for this video. Our first learning objective is that we can identify a quadratic function. Our second learning objective is that we can identify the roots and the zeros of a quadratic function. And our third learning objective is that we can solve a quadratic function. Before we get started talking specifically about quadratic functions, let's just review what a function is, since a quadratic function is a function. A function is a relationship between two variables usually x and y, where each input has exactly one output. All right, and then we may remember that our inputs, we generally call those our x values or our domain. And our output, where we're talking about y values and our range. We won't be talking about domain and range in this video, but we might later on in quadratic functions, so keep those vocabulary terms in mind. Also remember that there are 5 different ways that we learned to represent functions. We'll be focusing on 2 today. We'll be identifying quadratic functions based on their graphs and based on their equations. So let's tackle that first learning objective of how to identify a quadratic function. So a quadratic function will be an equation where we have a variable raised to the second power. Okay, so if you're familiar with the trinomials that we have been factoring, these are quadratic functions. So for example, we could have x squared plus 11x plus 30, which is an example we'll be talking about in a moment. I know that this is a quadratic function because it has an x squared term inside of it. So this is how I will recognize quadratic functions. Also, the equation y equals x squared is the parent quadratic function. So every other quadratic function is a variation of this parent function. We can also recognize quadratic functions from their graphs. Quadratic functions will always have graphs that make a U shape, either pointing up or pointing down. And this U shape that our graphs will make have a special name that are called parabolas. Okay, so when we're looking for the graph of a quadratic function, it will be in the shape of a parabola, either facing up or facing down. So in order to tackle the second and third learning objectives, we'll actually do them at the same time. For these learning objectives, we will find the roots and the zeros of our quadratic function by finding the solutions to this equation. So our first step in this process is to make sure that our trinomial expression, so here's our trinomial, is equal to 0 by getting all terms to one side of the equal sign. Luckily for us in this example, it has already been set equal to 0, and all of our terms are on the left side of the equal sign. So our next step to finding the roots and the zeros is to find the binomial factors of this trinomial. So in order to find the binomial factors of our trinomial expression, I need to find factors of 30 that will multiply to make 30 and add or subtract to make 11. So I know that 5 and 6 are a factor pair that make 30. They also add together in order to make 11x. If you're still struggling with factoring, we won't go over that much here. Go ahead and watch our videos on factoring. So now that we know what the factor pair that we will need to use is, we can make the two binomial factors inside of our parentheses. So we have x plus 5, because this is a positive 5, and x plus 6. And then I'll just bring down the equal sign and 0, and that's all for this step. Our next step is to set each of the binomial factors that we found equal to 0 and solve for the variable. So that's what we'll do here. We have x plus 5, and we need to set that equal to 0. So that's our first binomial factor. Then we have x plus 6, and we also need to set that equal to 0. So that's our second binomial factor. In order to solve for the variable, I need to perform inverse operations in both of these equations to get x by itself. So in my first equation, I will subtract 5 from both sides. So that leaves me with x is equal to -5. Let's do the same in our other equation. I will subtract 6 from both sides. So I get x is equal to -6. So x is equal to -5 and x is equal to -6. I just found the zeros and the roots. These are the same thing. Now that I'm all done factoring, let's take a look at the graph of this quadratic function and what it looks like. So if I have the quadratic function, which we just factored and found the zeros of, I notice that its graph is a parabola. So the shape is a parabola. I can tell right away that it's a quadratic function. And I also notice that this graph crosses the x-axis at -5 and -6. So you may remember when we previously discussed functions, we said zeros were the places where a graph crosses the x-axis, and this is still true for quadratics. So -6 and -5, these are the zeros and the roots. Remember, roots and zeros are the same thing, and so we can find the roots and the zeros by finding the binomial factors or by making a graph of our quadratic function. Before we go, let's try one more example. This time we have x squared plus 6x equals -5. So step 1, we need to get all of these terms on the same side of the equal sign so that our equation is equal to 0. If I want to get -5 to the other side of the equal sign, then I will need to perform inverse operations. I will add 5 to both sides of the equal sign. -5 plus 5 is 0. I can't add +5 to anything else that is already in my expression because I don't have any like terms. So I'll write this as x squared plus 6x plus 5. Now I'm ready to find the binomial factors of my trinomial expression over here. So I'm looking for factors of 5 that multiply to make 5, add to make 6. So I know that 5 is a prime number, which means its only factors are 5 and 1. 5 times 1 is 5, 5 plus 1 is 6. So the two binomial factors that I can create are x plus 5, x plus 1. And I'm going to bring down equals 0. Next, I need to set each of these binomial factors equal to 0. So x plus 5 equals 0, and x plus 1 equals 0. And finally, I'll perform inverse operations to get x by itself. So I'll subtract 5 in this equation, I'm left with x equals -5. I'll subtract 1 from both sides of the equal sign in my second equation, and I'm left with x is equal to -1. So something you might notice now that we've done this process twice is the roots or the zeros that I end up with at the end of this process have the opposite sign as whatever sign is in our binomial factors. So if we have a +5 in our binomial factor, then the solution for that binomial factor will actually end up being a -5. So our signs are inverse. Finally, if I wanted to draw a graph of this quadratic function, I know that this function would cross the x-axis at -1 and -5. So -1 and -5 are the roots and the zeros of this quadratic function. All right, everyone, I hope that was helpful. If you're still confused, go ahead and watch that video one more time. And if you're really struggling, send this at Mac an email. If you liked this video, go ahead and hit the like button. And if you haven't already subscribed to our YouTube channel, hit the subscribe button now. Thanks for watching.